Hello and welcome to a very special video today. Not one of the usual ones, but a big thank you from me to you because I've reached 1,000 subscribers. Thank you all. When I started with this channel, I would have never thought that I would reach that point at any time. Actually, I started it just for fun and just because I wanted to share the fun and the joy I have when implementing such things as what you are seeing currently in the background. I've quickly hacked together based on the celebration we want to go and to do there, a Fireworks system within our PixelLoop shell renderer thing. So in my terminal, you currently see a pixel firework going on. Again, thank you very, very much for helping me reach this step of 1,000 subscribers. And yeah, I hope you enjoy the videos I have. I'm going to create in the future, the ones that I created in the past. And I hope that as a community, we can grow even further. Maybe there are even more people there out there enjoying this stuff that we are doing here. So thank you again, and please spread the word. And if you're just stumbling by and seeing this and thinking, hey, I might enjoy that as well, then please subscribe and hit the like button so that even more people on YouTube will find this video. Thanks. Hello and welcome back to another coding session with Mr. Jacob. Today we want to do something special. We want to prepare for the nearing 1,000 subscribers on my channel. And I want to thank you beforehand already for this milestone that we are going to reach. I will post this video most likely as a celebration of those 1,000 subscribers. So you will see what the celebration is and what we have done beforehand, because I will most likely have cut some kind of video before that where I'm thanking you for that. But now let's begin. I thought, where or how could we celebrate our 1,000 subscribers on this channel? And I thought, what better than to implement some kind of fireworks celebration which goes up. And as we have done our last videos in the terminal via our PixelLoop engine, where we implemented a pixel rendering system within our terminal, I thought, why not implement fireworks display in our terminal? And that is what we are going to do today by using a very simple particle engine that we are implementing to fire up rockets and explode them into really nice and bright colors in the terminal. So let's go ahead and quickly go into this because we have a lot of work to do to get this running. So first of all, I guess I will go to the cargo terminal and create us a new binary here. So let's see, we call this one Fireworks. And this one will be Fireworks as well. And then I guess we can, again, copy our very simple example. So we have the trivial CLI demo example. So let's copy that quickly to source Fireworks as a base plate. And let's go to our, where is it? Didn't I open up a Visual Studio? There I opened already up a Visual Studio, and let's go to Fireworks main RS, which currently is our simple example. So we have to remove a lot of stuff. So let's clean out this state here. I guess we won't know yet what we need in the state. So let's just clean all of this out and let's simply return an empty self here. Let's go ahead and quickly go over our code in main. Yeah, we are creating an empty state now. We are creating an input, which we will need that for the escape key. We are starting the rendering loop. We are exiting if the Q is pressed. That is nice. We don't need that anymore. And all of that stuff for the box rendering we don't need anymore. We will fill in our firework count there later. Let's remove the render code again for our boxes. We don't need that, we don't need that, we don't need that. So yeah, and we don't need our benchmarking code there. So for now, This should actually compile. Let's remove the unused imports here as well. And let's quickly create a compile line here, cargo run, bin fireworks release, and let's just be sure that we reset the terminal afterwards, because if we make something crash like the last time, we can easily recover from that. And as we can see, we simply have an empty screen, and afterwards when I press Q, the terminal resets. Perfect. So we have building blocks for our fireworks. So I guess the first thing that we are gonna need is we need some sort of particles. We need particles which behave kind of with gravity and stuff like that, and speeds to go either up like a rocket or then explode into all kinds of directions. So I guess we are implementing particles first. So let's implement a particle, and let's see, we will need a position here, which, yeah, I guess will be something like an I64. We will need, do we need a size of a particle? That's the question. Maybe we want the particle to be sized to be able to display more than one pixel. Yeah, let's do that, because let's call it dimensions, because I'm not 100% sure how large we want everything in the end, so that we can easily configure that. Furthermore, what do we need? We need a position, we need dimensions. A particle usually needs some sort of lifetime, so I guess we will do it that. And maybe we should, yeah, let's do all this in the floating point domain for now, because it will make things easier for us. It's not said that, yeah, the dimensions can be integer domain, but it will make things easier for us. It can be done in integer domain as well, but it will make things easier for us. So it needs a lifetime, so that we know when it goes out of space and stops being there. It needs some sort of, yeah, let's call it a fading value, some value by which it loses its lifetime every step it's updated. It will need a speed, so that we know on the different axes in which directions it will be moving. Yeah, okay. And it will need some sort of acceleration, so that we know, okay, this thing will be accelerated each step into a specific direction. So a specific force is actually interacting with it. Like, for example, it's being pulled down by the gravity or stuff like that, or it's propelled by the explosion or something like that. We will see. Okay, so yeah, that should be it for the particle. I can't currently think of anything else. So let's implement the particle. So let's give it a public function new. And yeah, we will need a width and a height of the particle. I'm just thinking about, we need a position. So I guess we will take an X. Maybe we take the X as an I64, because we are taking the position in integer space and only storing it as floating point to more easily manipulate it. Yeah, that I guess could work out nicely. So let's take the X, the Y. Oh, our particle needs something else. Our particle needs a color, because otherwise we don't know how to render it. So it will take a color, of course. And does it take anything else? Do we want to put all the different other stuff into that as well? I don't think so. I think we will do it with a nice pattern, a little bit different to initialize, just to make it a little bit more readable, and to be able to initialize particles with a kind of an initial state there. So okay, we will see. Let me scroll this up so that you can read it a little bit up. Maybe not that up, so that I can read what we need to fill in here. So we need to first fill the position. The position is X as I64 and Y as, no, as F64, sorry, and Y as F64. There should be no problem converting those. Go away. The dimensions we have as well. Those are width and height. We can simply take them. And we want the lifetime, which is by default simply 1. And why do I have all these tooltips here? I don't know. Which is by default the lifetime, and it's 1, and we can decrement that. Let's maybe do the fading by, I have no idea. Let's for now just do 0.1. We can change this in the end easily. Let's do speed, which is by default 0, 0. So it's not moving at all during the default value. The acceleration will be 0, 0 as well. And we will have the color, which we simply take from our input. Okay, so now we have initialized that. So we need the possibility to, I guess, at least define the fading, the speed, and the acceleration. So let's quickly implement further methods for that. Let's call them with fading, I guess. This would be the fading value then, an F64, and it will return self. And now the interesting thing we can do here, we take not a reference to self, but we take self. We take the self value there. So we really take ownership of that, so that we can, in the end, have the full control over it. And when we then return a new one with a new value. So we can easily do that by doing something like we want to set the fading here and then give me the rest of the self values there. And now we have it with fading value, which we can use to kind of iteratively construct such an object. It's quite a nice pattern. I've seen somewhere over the time. I have no idea actually where I saw it, but I liked it. And I'm doing it in such situations. So let's do the same thing with the speed. So let's do something like with speed. Let's do x speed and y speed, or maybe only x and y. I guess it's quite obvious due to the function name what we are doing here. So then we are doing speed, which will be x and y. And the rest of self. Let's copy that. And let's do something like accelerate. Let's do the same thing for acceleration. There we go. And we need acceleration on X and Y as well, but this will be acceleration. So do we have now everything? I guess so. If we have forgotten something, we will add it later on. Okay, so now we have a particle. I guess the first thing that we need to be able to do is we need to be able to draw particles, I guess. So let's for now maybe just do something like implement pubfn draw, which takes generic canvas implementation as a mutable reference, I guess. So as we are doing always. So we have something like canvas, canvas, which is a mutable reference to a C here. And not sure if this actually can fail. If it does, we will see, we will return a result in the end. So what do we need to actually draw this? I guess in order to draw this, we need something like just the canvas filled rect, and I guess we just put in there, and of course, as always, I forgot that we need a self here. So I guess we need self and then position, and we round the position, and we simply take that one as an I64 then, because before we were in floating point domain, but we need to take the first element, so the X value, yes. And we need to do the same thing, I guess, for the position 1.round as I64. For the X, let's reformat. We need, I've somehow seemed to have removed the width there, but we need the self dimensions 0 for the width and the self dimensions 1 for the height. And we need self color, of course. No, we need a reference to self color to draw this thing. Yeah, so Maybe let's quickly test this with a kind of a test particle. So maybe we can call this one rocket or something like that. So let's do something like this will be a particle. And we are simply doing rocket is particle new, which will be somewhere like, I have no idea, 30, or let's, where would we actually move that thing? I don't know. Let's just give it a fixed value for now. So 30, 30. Let's make it 1 pixel by 1 pixel, and let's give it a color from RGB. Let's just make it white for now, I guess. We are just testing that our drawing code is working, and then later on that our movement and speed and acceleration code is working for now. So I guess we have this rocket particle here now. So I guess what we need to do is we need to tell the rocket to draw itself on our canvas. Yeah, that actually looks right. So if we now start this, we should get a simple white pixel at the position 30, 30. Okay, this works. That's already quite nice. So this quite easy code here works. So now let's think about the movement. So let's maybe initialize this thing with like I wanted to have an acceleration, like, I don't know, the x-axis acceleration is 0, I guess. And the y, I want something like, no idea, 0.02 or something. We'll see. We will have to play with the forces to make it realistically gravitational pull, for example. So if I have a positive force on the y, it's actually a force getting something pulled down. So the reason is that our coordinate system starts at the top left, and there is the 0, 0 point, and then going down there will be a positive value, and going right there will be a positive value in the axis. So if we have a force that goes into the y direction positively, it pulls something down the screen. So that's actually what we want here. And maybe we give it with speed into the opposite direction, like a rocket. It should go up like, no idea, maybe -2, because we want it to go up. So yeah, that should actually already work. So let's do that. And as you can see, this does not work because this should have been a floating point. But as you can see, this is quite a neat syntax to actually create what we want to do here with all those values. So yeah, let's do this now. And if we start this now, nothing will happen, but we will need to implement something. Let's implement an update function, I guess, for our particle. So pubfn, let's scroll up a little, update. Not sure if we need to give it something more than a mutable self, because it will be modifying its values. And yeah, so let's see. What do we actually need to do here? I guess what we need to do definitely is we need to calculate a new speed based on the acceleration values and stuff like that. We need to update the lifetime. What did we have here as well? So yeah, the speed is affected actually, the position is affected, and the lifetime is affected. So yeah, let's for now, I guess, just update the position based on the speed value that we have, or we could first adapt the speed and then update the position. I guess it's the same. So yeah, let's maybe do that first. So what we want is we want something like the speed will be, let's see, the speed will be self speed dot 0 plus self dot acceleration dot 0. So we need to apply that acceleration, and self speed dot 1 plus self dot acceleration dot 1. So this should actually bring our speed to a corresponding value so that our acceleration is applied to our speed. Then we need to do something like self lifetime is minus equal self fading, so that we actually have the lifetime going away there. And then we need to calculate the new position. So the position will be self position.0 plus self speed.0 and self position.1 plus self position.1. Yeah. And yeah, maybe we should guard these things like if self lifetime is less than or equal to 0, then we don't do anything here. And I guess we want the same thing in our drawing function, just to make sure that we are not drawing or updating and wasting computational cycles with particles which are actually dead but simply have been called in this loop because they are still part of the system anywhere. And if I've not forgotten anything, that is actually mostly anything or everything that we need to create more or less organically behaving particle there for our use case here, at least. So let's see. Okay, so I guess we can simply test this, because if I did it correctly and I'm now calling this update function here, I guess, on our rocket, the particle should actually go up first and then move down again, and it should slow down in its movement up. And maybe all of my values are completely wrong and it just will shoot out of the screen or don't move more or less at all. We will see. I have no idea actually. Yeah, and something like that must have happened actually. It's yeah, it's not even shown anymore. Maybe my lifetime is a lot too my fading value. I'm guessing that my fading value is a lot too big here. So let's maybe check this art first. Okay, no, that doesn't seem to be the problem there. So what's the problem here? Let me quickly check. What values do I have actually given this thing? I have given it something like, where is it? It's usually a 0 speed. Where is it going? It has something like 30-30 and it's 1-1, and I'm moving it with a speed of, yeah, let's make it a lot slower. Let's kind of make it something like 0.5 and maybe acceleration, I don't know, but this acceleration value should actually be fine. We will see. Maybe it just was too fast. Okay, I have glimpsely seen something move there, but I have no idea in which direction it moved. So let's for now just do a very, very little speed here. It's still very fast. Okay, let's check with a very minimal value, and it's just gone. I think I have some problem with my implementation there. How could I have made an error there? I guess I have somehow made an error there. Where are we? So we are checking for lifetime. Okay, we are calculating our speed. So we are taking the 0 speed and we are adding the acceleration 0 there. We are taking the 1 value of the speed and we are adding the acceleration 1 there. We are then removing the lifetime there and we are updating and there we go. There's our problem. I've added not the speed, but the position there. So let's go now. Okay, yeah, it's moving up, but it's moving very slowly. Okay, so let's see now where have I my values here. So let's maybe do it again with those values that I started out to begin with. Maybe this is actually not so bad. We will see. Okay, that wasn't so bad, but it should essentially, yeah, there it was. It came down again. So maybe we can make this a little bit smaller here just to have a little bit more pixel space. So like we can see okay, it's going out of the screen there. So I guess my initial acceleration is a little bit much. Yeah, that's actually mostly what I wanted to see. It's going up until it's then moving down again. So it's decelerating upwards and then downwards. So ladies and gentlemen, we have implemented our first pixel and or particle, and we will now create a lot more of those to do some rocket rendering. So that is actually what we need next. We now have a particle that we can use to create something of. So what we need now is we need a rocket. So let's create quickly a rocket. Struct rocket, which would, I guess, or maybe let's call this one Firework, because it will incorporate something like a rocket. Because the rocket essentially is only the one that goes up, I guess. That is the thing that accelerates the firework up, and then it will explode, and then we have all those nice little particles there. So I guess the rocket will be an optional particle, I guess. I'm not sure if we want to do this, do we? And I have just been thinking while talking and implementing here that the rocket will be going up to a specific point and then it will explode. So in the moment it explodes, it will disappear. So I thought maybe we can realize this using an optional and then just setting it none, and then it won't be rendered anymore. Yeah, let's see if this works out. And then I think we will need something like the explosion effect. So the effect and the effect will be a vector of particles, I guess. Particle. Yeah, let's maybe just try this one and impl Firework, and we will see if this actually works out as I would like it to. So pubfn new, and it takes, what does it take actually? I guess it will need an X, so a starting X and a starting Y. Yeah, so I guess this will be an I64 and a Y, which will be, come on, an I64. And now the question is, should we put a base color in there? I guess we should. A rocket should have some sort of, let's call it base color. Or effect color, which is the base for our explosion effect. So yeah, let's put it in there and let's return a new self, and let's do the effect color here, and we will then just use HSL color calculations to make this actually be a little bit brighter or a little bit more saturated and a little bit less saturated and stuff like that for all the different particles that we are have going out in the explosion, and then it will look really nice. So maybe this should actually be an HSL color, because we have an HSL color in our repertoire. So let's use that. Okay. So now what we need to do, first of all, I guess we can start with that because I just created it. We can do the effect color is the effect color, and let's maybe call this one base color then, because it will be the base color for our effects. So base color, and we have effect color as HSL. Yeah, as HSL I called it. So we have that already. So now we need the rocket, and the rocket will start with some particle. And now we need to think a little. The particle will actually start at the given X and Y position. That's nice. Then we have a width, which I guess would be 1, and maybe we will make this thing a little bit larger, like a rocket. So it's going up. Yeah, well, why not? Let's make something like 3, I guess. And the color of the rockets. I guess I want the color of the rockets to be always the same, like for example 1, because they are not the visual spectacle that we are looking for here. So let's for now initialize them with the color. white. And now we need effect. And effect will be, for now, I guess, an empty vector. Yeah, okay. Then we need, as always, a pubfn draw. And pubfn draw, as always, takes our generic canvas implementation as a mutable reference to this. And yeah, so let's implement that. And yeah, I guess what we want is something like if some rocket. So if we have, if let some rocket. So if we have a rocket, yeah, if we have a rocket, that's where our optional comes into play. Like, and as always, I forgot the self-reference here. Self.rocket. So if we can actually pattern match this and extract the rocket from this one, then we want, oh, I guess, does this not work? Or, yeah, let's see. Then we want rocket draw. Where's the problem here? Cannot move out of self rocket as enum variant sum, which is behind a shared reference. Yeah, we only want, it's fine. We only want to reference the rocket here. We only need a reference to it to call the draw function on it. That's perfectly fine. Okay. And then we want to go ahead and say for, let's call it particle in self.effect. We want particle draw canvas, and I guess we will have the same problem here. So let's get an iterator of that, and then we will be fine because we are getting an iterator on references. Okay. So now we can actually draw Firework. But what we need to do, of course, as well is we need to update this thing, and that's where it gets interesting, I guess. So let's see. I guess we have two different things to actually check there. First, we have a two-step kind of animation. We want the rocket to start and go up. And then at a specific point in its lifetime, we want it to explode and generate all those particle effects as an explosion. So what we could actually do here is implement just that. So if we should maybe base this on the acceleration. No, on the speed of the rocket. So if the rocket is still going up, it has to still thrust. And when its thrust is getting less and less and less, it will reach the 0 point at some position or flip into the negative there. So this is the peak point. And I guess somewhere before this peak, we wanted to explode to have it look a little bit natural, I guess. So yeah, let's implement this somehow. So if first of all, I guess we need to get the rocket out again. So if let not, where did I have my fingers on the keyboard there? Some ref rocket self.end. Yeah, I need a self reference here. Self rocket. Then we need to let's for now here update rocket, because I'm quite sure what we need otherwise. Otherwise we need for particle in self.effect. That is something that we want to do always, actually, is we want to update the particle, and we need an iter mut for that, because we need to iterate that. And this is something that you don't want me to do. Cannot borrow self-effect as mutable as it is behind a... Oh yeah, that makes actually sense. Update needs a mutable reference. Yeah, that makes perfect sense. So we are always updating our effect particles. If the vector is empty, nothing will happen there. And if we have effects in there, we need to update those. Okay, that makes sense. So now how does the rocket fly? I guess, first of all, if we have a rocket, we want to tell it to update as well. So just to make sure that, and we need, can we actually do something like, I've never tried this, I guess. Okay, we can actually extract a mutable reference out of there. Nice. Okay, so we need to update the rocket, and then we will see if rocket dot speed dot 1, because we want the up movement, I guess. If this one is, it will start negative, and it will near the 0 point, and then at some point it gets positive and falls down again. So I guess maybe if it's bigger than something like 0.3 or something like that, so it's not completely grinded to a halt, but just before its peak where it goes down again, it should explode, maybe. So yeah. So what would actually be the thing here that needs to be done when this explodes? So first of all, we need something like explode rocket creating effect, something like that. And then we want to, I'm just doing it like this so I'm not forgetting, because it's like the way I'm just having it in my head. So then we want to set the rocket to none, because it has actually exploded, and then in the next update cycle it should not be there anymore. Okay, that makes actually sense. Okay, so now we need to explode the rocket creating the effect. So what that means is actually that we actually need something like self effect. No, we need some sort of loop, I guess, for we don't care in a range of how many do we want? 25 maybe? Let's for now see how this looks. 25 explosion particles. So for all of those, what we want to do is self effect push. So we are pushing a value in there, and we are pushing a new particle in there. And the X and Y position should always be the position our rocket currently is at. So because they are exploding from the rocket outwards. Okay, then we have the width and height, which should be 1 by 1, I guess. Then we have the color, and there it gets a little tricky, because we have to calculate this color based on the base color that we have. So what we actually want there is something like a new HSL color, and the hue we will take from self base color hue, and then we have the, let me quickly format this. Why is it not liking this here? No field position on tab 5. Oh, don't I have it? Didn't I? Oh, I don't have actually a. Oh, no. Yeah. We need not self position, of course, because we have the rocket position, not the, it's not on our fireworks thingy. It's okay. But now let's get back to this color. So we have the hue here. Now we need a saturation. So what we can actually do here is we take we need some sort of random. We got random in our engine, so I think I should actually put that. What kind of type is that? I should just pass that through. We have this engine thingy type here. What is it? It's a mutable engine environment. Okay, so I guess we simply take a mutable engine environment here, and I guess this will be we need to import this. Okay, and this engine, don't I have? Okay, I've just not finished that yet. That's what it's complaining about. I see. So HSL color. So we want the base color. Then we want self.baseColor saturation, and then we need to add some sort of randomly generated bias, the difference there, which we can move the saturation around with. So how would we do that actually? Let's see, we have the engine environment, and if I remember correctly, we have a rend in this engine environment, and so we should be able to generate just a floating point here, maybe? Okay, this does not work. Oh yeah, we need to, of course, import the corresponding trait. And we just multiply this with, I don't know, maybe the saturation we can vary by 20 or something like that. So, actually, but what I actually would want is, actually, I would like to have this. So let's maybe do something like minus 0.5 times 2, so that we actually have a value which could be positive and negative, and then let's just clamp that one between 0 and I don't know what is actually the color is, I guess, in 0 to 100. So what did I do there? I pressed the wrong button. I wanted to go back. So we want to clamp it between 0 and 100, and I guess we have one brace too many here. Wait, so this is the, actually we have 2 braces too many there. Okay, and I guess we want to do the same thing more or less with the lightness, but maybe we can vary the lightness by, I have no idea, 40. Yeah. So this will either go somewhere in the range of minus 40 to 40 up or down, and the other one will be in the range 20 or minus 20, minus 20 or 20. So it can move in this range. Yeah, so, and then we need to just tell it to convert into a color, because we're expecting a color, not an HSL color, and HSL color implements that. Okay, this looks kind of right to me. What's the problem here? Expected I64 found. Yeah, okay, I get that. So as I6, so we need to kind of round that anyways, and then that's actually a little bit not so nice. Maybe we should have taken a floating point there as well. Okay, so now we have created a new particle effect, and now we need to give it some more. We need to give it an acceleration, definitely. So what we wanted, and it looked kind of okay to me, so for now let's stick with the 002. We need to pull it down actually. Okay, so that's our gravity, kind of pulling the particle down, and we want with an initial speed it got out of the explosion, and I guess we will kind of do that randomly again. Yeah, so I guess we want to have it fly out equally into both directions randomly. So let's maybe do something like I don't know, 3 times ee.rand .gen f64. Come on. Want an f64 there, and we multiply this by no, we simply subtract 0.5, so we have something in the range, and multiplying it by 2, so that we have something in the range of -1 to -1 to 1. Yeah, I guess that would be nice. Yeah, and let's do the same thing here with the y coordinate. And I guess as we have working gravity against it, I think we wanted to go more outwards, so more up. So let's maybe bias this a little by having a little bit better chance of being negative, actually. Maybe something like 0.9. We will see. We can, as I've said, I have no idea how this really looks in the end, and we will adapt all of those. All of those values properly in the end and have to play around with them once we have implemented. So what we have now is here we have a particle which is pulled down by gravity, and it has a certain speed moving outwards, moving upwards and outwards from this, and we actually have 25 of those. And we have this color here, and yeah. So I guess we could actually try and have some fireworks here now. So fireworks is a vector of firework. And now we need, yeah, I guess we will, fireworks is an empty vector for now, and we will fill it up in our update cycle because we need to have it going randomly and we need positions and stuff like that. So what we want now here is actually is something like we want for firework in self fireworks dot iter. Actually we need an iter mut because we are calling an update. We want firework dot update. Wait, is there some problem? Oh, it's not self, it's state. Yeah. And the update, we gave the update something, didn't we? We gave it the engine here, but I'm not sure why I call it E here, because it is the engine environment, and usually I call it EE. Yeah. So I guess we can do it like, what's happening to my editor here? Okay, we can do it like that. And then we definitely need to do more or less the same thing here. We need to draw all our fireworks. So we are drawing it and giving it the canvas there. Come on, canvas. And there we don't need an iter mut, we just need an iter. And now we should actually have something there when we actually have firework in there, and that is something that we now need to process, of course. So I guess we should add a new rocket every x random interval. So I guess what we could do is something like if rand dot gen f64 is less than, I don't know, maybe 0.10, so kind of 10. We want to kind of 10% of the time we want to spawn a new rocket. Let's try that. Let's see if that's enough or not enough or whatever. So in this case we want to state firework.push firework new, and yeah, let's see where are we actually placing that. The y will definitely be the height of the canvas. That's for sure. The x value would be, is this a different? Oh, found U32. Okay, I see. That's no problem. That can easily be converted. A U32 definitely fits into an I64. That's no problem. So, and we want the x kind of to be somewhere between the somewhere on our screen. So I guess we can do a random value here again as well. As you can see, we are doing a lot of random stuff there, but it should work out in the end. So let's maybe do a random generation F64, or no, maybe we are actually having an i64 here, which doesn't make a lot of sense because we definitely need it to be positive. So maybe just do something like a U32, because that is how our width is limited anyways. And then we will simply do modulo the width here. Okay, this does not work. Expected, okay. Then we need to, after that, oh my god, cast this into an i64. Okay, so this should actually give us a value somewhere between 0 and the width of the terminal. We will see if I'm right, if this is actually working. So now we need the effect color, and I guess the effect color can simply be completely random color. And let's see, yeah, what it gets there. So we want rand gen, and we simply tell it to generate us a random U8. And we do this 3 times and close the braces there. Yeah, so maybe we will have firework, or something will now completely explode. We will see. Okay. That's kind of looking nice and a celebration as well, but it's not what I had in mind actually, but it looks nice. Okay. So let's maybe see what went wrong there. So I didn't see any rockets actually there, which is an indicator for me that there is something wrong with our rocket update function somewhere. So what we are actually doing here is we are updating the rocket once the firework is updated. So the rocket should actually go up. If the rocket speed is then reaching its limit, we are doing this. So and otherwise we are simply showing the particles. So maybe we should, for now, just comment this. Come on, comment this out here just to see. Wait, what did I now do? If rocket. Okay, maybe there is some. Maybe there is already. Okay, so I guess I may have already found the error or not. So wait a second. We have this one here, which ends here actually, and okay, wait. This does not make sense. We have this extraction check, and this extraction check should end here. And okay, let's check where all of those blocks end, because something is broken here. This block is the 4. That's exactly fine. This is generating all the stuff. This is the if, which checks if we should actually generate this. So this should end there. And yeah, so actually this none should be part of this if. So if the rocket speed and so on, okay. So if this is the case, then we want to remove the rocket after we have added the particles. Exactly. And otherwise, we are just updating the rocket and then leaving this thing. Okay, was the brace there at the correct position before? I'm not sure now. So let's see. Okay, it's the same behavior as before, and they all kind of seem to explode from the bottom there, which is kind of irritating, and they are exploding with a lot too much force, but we can easily fix that. For now, we need to have the rockets fly. Do we initialize the rocket wrong, maybe? So where do we actually initialize the rocket? I guess when we are creating the fireworks. So the rocket particle actually... Our rocket particle actually has no... it has no movement speed. It has no speed and no acceleration. Okay, that's, I guess that's our problem. So we need something like with acceleration here, we want it to be pulled down as well. And we want something like with speed, so it should go 0 in the X direction, and it should go, yeah, maybe something like, yeah, I guess what I need here is I need an EE engine environment here as well to create Firework, because I need random stuff here. So what I want to do here now is generate myself a nice little F64 as well. And let's see, what do we want? We want the speed to be somewhere between, maybe give it a starting value, something like minus 0.2 plus a random value times -1, so that it can go between somewhere between -2 and -3 up, something like that. Yeah, maybe. So where are we now creating this Firework? Because there we need to supply an EE, and I've just put it to the back of it, didn't I? That was not a good idea to put it at the end. Something like that should be in front. So let's just supply it here with a mutable engine environment. Okay. Now this cannot borrow EE as mutable more than once at a time. Wait, what? Oh. Okay, that's a problem. That's, yeah, because he is putting it in there, but we have it. Okay, so I guess we will do it a little bit differently. We will supply it the up movement speed here during construction. Why not? Where is our news? So there is most likely a nice way to fix this, but I don't want to think about that now too much. So we just call it Y speed, and it's an F64, and it kind of will be this one. So with speed 0.0 Y speed there. And let's then go ahead and have somewhere where we call this one. There we now need to put kind of this here, and this should then hopefully compile and work. Let's see. Okay, now we have flying Firework. However, they are flying a little bit too high for my taste, so let's give them a little less speed, maybe. Maybe let's just give them... yeah, this actually looks kind of nice, but they are exploding much too... with way too much intensity. So there we are creating our thing here. Maybe we will just... No, not the color. That's wrong. Here. So maybe we will just kind of... I don't know, half that, or we could actually just remove. We could just remove those multipliers there. Maybe that essentially halves the values. Okay, that looks better, but still it's a lot too intense for my taste. So maybe we just do something like 1. Or, wait, we were multiplying this. Actually, I had more in mind something like a base speed to make them move. Okay, now I did something something terribly wrong. So what's the problem here now? Wait. So let's go back to this, because maybe we will see. We are generating a random value here, and we are, for the x, we are actually subtracting 0.5. So it should be a random value here now between, it should be a random, yeah, it should be a random value now between 3 and, what we need to do actually is we need to kind of flip the thing. Yeah, I see. So maybe we should do something like Yet the problem is the following. I want some sort of starting value, like I don't know. But then I want to have it. I wanted to actually have a specific value, which can either go left or right, which is always fixed. And then I want to add or subtract another value just to vary the explosion a little. So actually what I need to do there, I guess I need two random calls there, because I want something like 2, and I want this 2 multiplied by either 1 or -1. So I want it to be positive or negative. But can I do that actually in one generation cycle here, which would be actually kind of nice. So, or do I simply do something like, maybe I don't do that. Maybe I really do it. No, I need this one. So I need a kind of a bias that I definitely need. But the question is, maybe we can do it with something like 1.5 times and 1.5 times, something like that. Maybe we just need to adjust it a little bit more. Yeah, that actually kind of looks already quite nice. The problem is, however, that we are not removing any particles yet. They won't be rendered once their lifetime is over. Oh, by the way, we need to check that lifetime stuff. But what I want to do is I want to actually fade them out. So what I want to do, this makes it look a lot more real, like they need to go more transparent, or at least they need to be more blackish once their lifetime is fading. So maybe let's implement that first, and then we need to do some cleanup, because currently we are only creating particles over particles over particles over particles, and we need to remove particles that are not displayed any longer, so that actually their lifetime is gone, because otherwise it will slow down to a crisp there once it has enough particles accumulated. However, this already looks kind of nice. It's a little bit intense. And maybe we can tweak the explosion levels there a little, and maybe even make them a little less intrusive, but we will see this once we have our fading implemented, because then we will tweak the lifetime values as well. And the fading will actually be done in the particle drawing function. Where is our particle drawing function? Draw. So that is our particle drawing function, and what we now need to do is we need to kind of calculate a new color based on the lifetime value combined with the color value. So what we are just doing here is we are creating a new color every time we draw this thing. And we will from RGB, and we will simply do self color R times, let's see, the lifetime is a floating point, so we can simply do, and it's between 0 and 1. So what we actually can do, which is quite nice, is we can actually do something like we want self lifetime here, and we need this as an F64 then, and we calculate it in combination with this self lifetime, and then we need to round that, I guess, and then maybe even clamp it again between 0 and 255, and then we can say make it, because we could accidentally have made it negative if the lifetime got negative. We are nowhere checking that our lifetime is actually not going to get negative. And then we are making a U8 out of it again, And why can't we actually clamp this one? Can't I clamp? Do I need? No, wait. Yeah, we are kind of automatically clamping it, but it could cause some strange behavior. Okay, why? First of all, why is this not working? Color field R is okay. Yeah. So that is quickly fixed. So why do this method expected found integer? Okay, yeah, that makes sense. We need to clamp it between floating point values, and then we are converting it. Okay, so now let's do this RG and B, RGB, wait a second, RGB. So something like this. And now actually those things should fade out. Those particles should fade out based on their lifetime. Yeah, they are a little bit kind of, but their lifetime is, I guess, not being diminished enough because we made this value very small. So let's see what happens if I just remove yeah, that's actually quite nice. Now, as you can see, they are fading out and they are beginning to look a lot more like Firework. This actually looks a lot more like Firework. I really like that. I really like that. Yeah, so but the rockets are fading out as well. We need to fix this, of course, so that the rockets are not or maybe that's actually not so bad. I'm not sure. We'll think about that. Yeah, so now let's do a little bit of cleanup and then we are finished, I guess. So the effect is already finished. The thing that we now need to do is we need to be able to somehow remove Firework from our, where are we? From our state here. There we have this vector and we want to clean this vector based on Firework that does not live anymore. So I guess what we can do every update cycle is we are doing the following. We are going ahead and telling the state Firework to, there was something like a retain function, wasn't there? Yeah. So retain actually removes all elements where we have a function that returns false. So it goes through all the elements in the array and then it removes everything where we return false. So it only retains what returns true. And that's actually quite nice because now we can do something like we get Firework here and we can simply ask the Firework to be not dead. And yeah, of course, we haven't implemented the isDead function yet, but that's actually something that we can easily do. So we implement in the Fireworks implementation a new function there called pubfn is dead. And it takes a reference to self and simply returns a Boolean. And what it does is it checks, first of all, so what it returns is actually, it returns self.rocket is none. Because if there is no rocket and self.effect isn't there an all or something like that? There is definitely something on the there is a function there, array rust vector docs rs into an iterator and all. There is, oh, maybe I need to, yeah, a iter, or, okay, so I need to, yeah, that makes kind of sense then. So there is an all there, and that is actually that the given predicate needs to hold up for all of the effects. So what I want to do is, if the rocket is none and all effects are actually dead, effect is dead, then, yeah, we need to implement that, of course, on particles. But if that is the case, then the then this thing will be dead, actually. and we want to return this. So I should remove the semicolon there. So now let's implement on a particle the isDead function, which is in this case really dead simple. Pub fn is dead self, and it returns a bool, and it is simply returning self.lifetime is less than or equal 0. So this is actually the isDead function of a particle because we are already tracking the lifetime. And now actually we could kind of output that just to check. We should have a limited amount of fireworks in the retained here. So let's maybe do something like every time we cleaned up, we are simply doing like fireworks active, and we are printing this to the stdr, so so that we can actually put it somewhere else while our terminal still displays the firework. And this will be s.fireworks.len. Okay, nice. And now we should be able to do something like we want to, let me make this a little bit bigger again so that you can read. I'm now redirecting the stdr, so the second one, to something like foo.log. Yeah, this should actually work. And then let me make it smaller again, and let's execute this one. And now let's have it running a little, and it should actually kind of near a specific value, and then this value should actually never be going higher. But as you can see, we already have fireworks. So yeah, I'm already really looking forward to publishing this video once we reached 1,000 subscribers, because I find it kind of awesome to have a fireworks simulation in our terminal. That is that is absolutely great. I love it. I really love it. So yeah, I love that. Okay, so let me now quit this. And let me quickly just kind of tail the, how did I call it, foo log? Yeah, and as you can see, yeah, we can even show the whole thing, that it actually, there were no more than about like 13 or 15 or 16 fireworks at one time. So we had more, and then it cleaned up again, and then it got more again. And so that's actually quite nice. We are actually cleaning up those fireworks so that it is actually nicely preserving our memory and not going haywire. And computationally, it would be calling all those update functions, all those particles, which would get slow at some point as well. So yeah, I guess we are mostly done. Maybe we could give our rockets an unlimited lifetime. That would actually be a good idea, because we are exploding them kind of. Where are they? Rocket. Hello, rocket, where are you? Why can't I? Oh, they are part of the firework thingy, aren't they? Yeah. So we could actually do something like with fading, and we simply give it a 0 fading value. So now they should actually stay. They should actually stay. Yeah, they are now staying until they exploded. Which, yeah, I guess this looks better. So, because the rockets actually are not fading particles. The rockets are going up. They have a specified lifetime, but they have the lifetime until they explode. I would love to see how many of those explosions I can actually get there. So let me make my terminal a lot smaller. Let's see. Let's run this. That's looking really great. But now we have to give them a little bit more base speed, don't we? So what happens if we kind of go ahead and give those things more power, sort of? So that's the firework. Where are we? I was already at the position where we created the rockets, wasn't I? So Yeah, it must be here somewhere. Okay, so now let's give it the Y speed. Okay, so Firework. Come on, Firework. Okay, let me go there manually. We are going there. We are pushing Firework new, and this is the speed here. So let me maybe add like 3 to this as a base value, and let's do it not only 10% of the time, but let's do it like 30% of the time to create a lot more firework, and let's see how this looks. Okay, that I gave it too much base speed. So let's maybe do 2 here and let's see. Okay, beautiful. Now that is what I call a firework. And it's performing really well. It's actually really fast. I like that. Even though I'm not sure, the small one was very nice as well. I like that a lot as well. So I like it in this size. I'm not sure. I think the pixel aesthetics of that. So okay, there you have it. A very simple a particle engine, and we are actually displaying and creating fireworks, and I love it. It's awesome. So again, thank you very much for this, for having me reach the 1,000 subscribers, and it's just awesome to have you as a community, and to know that you are watching those videos and that you have at least as much fun as I have while doing those. So let's look forward to the next 1,000 or wherever the journey might take us, and have a really nice day. I hope to see you in the next one. Bye.